Hello friends. So in this part second of numerical on diffraction, we will be learning the numericals particularly on grating. So here in the numericals part 2, that is the numericals on diffraction part 2, we will be having few questions to discuss. So here the question is, how many orders will be visible? How many orders will be visible if wavelength of incident radiation is 5000 angstrom and the number of lines on the grating is 2620 to an inch. To an inch means what? The number of lines in 1 inch is 2620. So the solution, first will be writing the given data, and the given data will be wavelength. Lambda is given 5000 angstrom. We have to convert it into 5 into 10 raised to minus 7 meter. SI unit is meter. And the number of lines per inch is equals to 2620. तो इसका भी कन्वर्जन करना पड़ेगा, नंबर ऑफ लाइंस पर इंच का नंबर ऑफ लाइंस पर सेंटीमीटर में ले जाएंगे. So wavelength we have to convert into centimeter because number of lines per inch will be also converted into centimeter. तो सारा कैलकुलेशन सेंटीमीटर में ही होने वाला है. So it is 5 into 10 raised to minus 7 centimeter. 5 into 10 raised to minus 7 centimeter. And the number of lines per inch will be converted into number of lines per centimeter. कैसे आएगा? Yes, it will be 2.54 divided by 2620, right? And what is required? क्या required है? Question देख लें तो समझ में आ जाएगा. How many orders will be visible if the wavelength of incident radiation is 5000 angstrom and number of lines on the grating per inch are 2620. So to solve this will be our given data and how to solve it. So number of lines per inch और number of lines per centimeter, ये किसका मीनिंग समझाते हैं हमको? This is the grating element. Therefore A plus B क्या होता है वो? 1 upon number of lines per inch, और इसको इंच से सेंटीमीटर में ले जाना है तो it is 2.54 upon number of lines per centimeter, right? This is the amount of grating element. So we'll find A plus B is equals to 2.54 upon कितना दे रखा है? 2620, जैसे कि यहाँ पर हमको दिया गया था. And what is required? How many orders will be visible? तो वो कैसे निकालो? So for that we will be using condition of maxima. So the condition of maxima क्या है? Condition of maxima, condition of maxima है A plus B into sin theta is equals to say n lambda. इसमें हमको n ढूंढना है कितना विजिबल है. अब फॉर मैक्सिमम चाहिए तो sin थीटा मस्ट बी 1, राइट? तो sin थीटा बन जाएगा तो A plus B will be equals to n into lambda, right? Now if A plus B is equals to n into lambda और A plus B तो हमारे पास है ही, इसको इक्वेशन 1 बोल देंगे. So putting equation 1 in this, what we get? Therefore A plus B is equals to n lambda आएगा, sin थीटा 1 हो गया और A plus B का वैल्यू है 2.54 अपॉन 2620 and that is equals to n into wavelength कितना था? 5 into 10 raised to minus 5. Now sending all of these to the LHS, we get n is equals to 2.54 divided by 2620 into 5 into 10 raised to minus 5. Therefore n is equals to 2.54, 10 raised to 5 ऊपर आएगा तो into 10 raised to plus 5 divided by 2620 into 5. Now we'll do this calculation on calculator. एग्जाम में भी हमको कैलकुलेटर अवेलेबल है यार. तो 2.54 divided by 2620 and divided by 5, get 1.93 and into 10 raised to 5. So answer we obtain is n is equals to 19.38. अब 19.38 दिखा रहा मतलब 0.38 मतलब आधा बैंड भी नहीं है, तो जाहिर सी बात है हम इसको राउंड अप कर लेंगे टुवर्ड्स 19. So n is equals to 19. This is number of observable order, right? So this is how to find the number of observable order. कैसे करना है? जैसे आप न्यूमेरिकल में देंगे वेवलेंथ दिया हुआ होगा, so lambda will be there and number of lines on the grating is 2620. 2 an inch बोला है तो उसको कन्वर्ट करना पड़ेगा, और अगर पर सेंटीमीटर दे दिया तो आप डायरेक्टली सॉल्व कर सकते हैं using a plus b is 1 upon number of lines per centimeter, and then you have to equate that a plus b sin theta is n lambda, put sin theta equals to 1 for maxima, right? So I hope you understood the procedure of this numerical, क्योंकि ये बहुत बार रिपीट भी हुआ है फाइनल एग्जाम में सेमिस्टर के. तो दिस इज 2 marks important numerical on the diffraction grating. Now moving towards next numerical, we'll be getting this. How many orders will be observed by grating having 4000 lines per centimeter? याद है पिछले वाले में नंबर ऑफ लाइंस 2 an inch बोला था और यहाँ पर पर सेंटीमीटर, तो यहाँ पर कन्वर्जन की जरूरत नहीं है, डायरेक्ट आंसर आए. नाउ इफ इट इज illuminated by light of wavelength in the range of 5000 Armstrong to 7500 Armstrong. So यहाँ पर दो वेवलेंथ है, so we are having two wavelengths. So obviously how many orders will be observed will be in the range, because wavelength range में आ गया. So if wavelength is in range, so number of observed maximas or orders of maxima observed will be in the range, right? So similar procedure we have to repeat. What is that? The given data, number of lines per centimeter is nothing but the grating element a plus b. So a plus b here is 1 upon number of lines per centimeter, and then lambda 1 is 5000 Armstrong, lambda 2 is 7500 Armstrong. तो इस lambda 1 को कन्वर्ट कर लेंगे 5 into 10 raised to minus 5 सेंटीमीटर. राइट, हमें नंबर ऑफ लाइंस पर सेंटीमीटर में दे रखी. नाउ lambda 2 will be 7.5 into 10 raised to minus 5 centimeter, and orders visible, that will be n1 and n2. हमें एक रेंज एक्सप्रेस करना होगा. we have to explain that the number of observable orders will be from this range to this range for the wavelength of 5000 Armstrong to 7500 Armstrong. So let's have same steps repeated over here also. So a plus b, first we have to find grating element, and that is 1 upon number of lines per centimeter. So a plus b is equals to 1 upon 4000. Then for maxima, a plus b sin theta is equals to n lambda, right? But then here there are two wavelengths and there will be two number of orders, so take it as n1 lambda 1, n1 lambda 1. And for maximum, sin theta should be 1, because sin theta का वैल्यू मैक्सिमम कितना होता है 1. Then put a plus b is equals to, put a plus b is equals to, yes, how much it is, 1 upon 4000. Therefore 1 upon 4000 into sin theta is 1 is equals to n1 into lambda 1 is 5 into 10 raised to minus 5 centimeter, right? So I will get n1 will be 1 upon 4000 into 5 into 10 raised to minus 5. and therefore n1 is equals to 1 upon this 10 raised to minus 5 will go up, it will become plus 5 upon 20,000. Can I say it's very simple, it's 1 lakh upon 20,000, right? So these 4 zeros get cancelled and this is 10 by 2, so n1 is 5, right? And similar calculation we have to do for second wavelength. Again a plus b sin theta is equals to n2 lambda 2. So n2 will be a plus b sin theta upon lambda 2, and therefore n2 is equals to, can I say, a plus b sin theta upon lambda 2, put a plus b is equals to कितना था 1 upon 4000 lines per centimeter, sin theta is equals to 1 maximum, and lambda 2 is equals to 7.5 into 10 raised to minus 5 centimeter, and therefore n2 कितना आएगा, a plus b का वैल्यू 1 upon 4000 into sin theta 1 upon lambda 2 is 7.5 into 10 raised to minus 5. How to calculate it? It is 3.333. So we have to neglect that 33 and n2 becomes 3. The number of observable order ranges, will range from 3 to 5, that is n2 is 3 to n1 is 5. I hope you get the answer. Is it simple? Then we'll move towards next numerical, and the next numerical is calculate the minimum number of lines in grating which will just resolve in the first order, the lines whose wavelength are 5890 Armstrong and 5896 Armstrong. So for this, what is the given data? So number of order for resolution is first order. The order given for resolution is first order. So according to numerical, we have to calculate the minimum number of lines that should be drawn on grating which will just resolve in the first order, means resolution should be produced in first order itself, and the lines which are considered there for diffraction are having wavelength 5890 Armstrong and 5896 Armstrong. So this is first order, wavelength is lambda 1 is 5890 Armstrong, 2 lambda 2 5896 Armstrong. This is the divergence of wavelength given, and we have to find its mean. And what is the number of lines to be drawn is asked for resolution. So we have the formula for resolving power, and what is that? For resolving power, it is lambda upon d lambda, and it is also number of order into number of lines, or order into number of lines on grating per centimeter, and we have to find this n, that how many number of lines to be drawn on grating. So how to solve it? For this, you have to find lambda, and lambda will be the mean of lambda 1 plus lambda 2 divided by 2. So it is lambda 1 5890 plus lambda 2 5896 and divided by 2. You will be having lambda equals to 5893, right? Now what will be d lambda? That is the change in wavelength you have to calculate, and it would be lambda 2 minus lambda 1, that is 5896 minus 5890, that is 6 Armstrong. What is the beauty of this numerical is the resolving power is the ratio of lambda upon d lambda. So you don't have to convert this Armstrong into meter, because numerator and denominator both are in Armstrong. So what is lambda you have obtained? It is 5893, and what is d lambda you obtained is 6. As this Rp is also equals to order of maxima into number of lines on grating, therefore m into n is lambda upon d lambda, and then n is equals to lambda upon d lambda ka value 5893, that was the value, upon 6 into this m goes to RHS, it will become 1 upon m. Put m is equals to kitna order de rakha hai, the first order is given there, so m is 1, so n will become 5893 upon 6 itself, it would be 982.16. so this 0.16 will be neglected and it will be equivalent to 982 lines per centimeter, or you can say it is number of lines on grating to be required to produce resolution, right? Then moving towards the next numerical. So the next numerical is a diffraction grating has 5000 lines per centimeter and the width is 5 centimeter. Now try to guess the given data here only. The diffraction grating has 5000 lines per centimeter, means each centimeter has 5000 lines and the total width is 5 centimeter. So total number of lines would be, yes, if 1 centimeter has 5000 lines, 5 centimeter will be having 5000 into 5, that is 25,000 lines. So total number of lines on this grating will be 5 into 5000, and we have to calculate for wavelength 6000 Armstrong unit in second order, that what is the resolving power and what is the smallest wavelength for resolution. So our given data is like our A plus B is 1 upon 5000 centimeter, that is grating element is 1 upon 5000 centimeter, total width is 5 centimeter, wavelength is 6000 Armstrong, then we have to convert it into 6 into 10 raised to minus 5 centimeter, and the order given is for second order we have to calculate, and what is to calculate is resolving power and smallest wavelength that can be resolved. So how to find it? Let's have the resolving power is also given as order into number of lines. So the order we are having is 2, and what is number of lines? That is 5000 in 1 centimeter. So total lines will be 5000 into 5. So you will be having 5000 into 5 into 2, that is 50,000 is in total. This is your resolving power. Also the resolving power is given as lambda upon d lambda. So resolving power to mil gaya 50,000, and what is d lambda? How to find it? Obviously d lambda will be lambda upon Rp. So lambda how much it was? 6000 Armstrong. Can I say 6 into 10 raised to minus 5 and divided by Rp is 50,000. So let's calculate it. Your resolving power is order into number of lines. What is order? Second order is given. What is number of lines? 5000 per centimeter, and in total it is 5 centimeter of width. So we'll be having 2 5s are 10 into 5000, it will be 50,000 will be the resolving power. Also resolving power is given by lambda upon d lambda. So you can find d lambda, that is the smallest wavelength for resolution, that would be lambda upon Rp. What is lambda? It was 6000. What is the resolving power? 50,000, right? And then calculate it. So smallest wavelength that can be resolved is 0.12 Armstrong. I hope you get the point. This is about the given numerical, and this is the solution. We found the resolving power and we found the smallest wavelength that can be resolved. Now moving towards next question. So in example 1.11, it is given that a diffraction grating which has 4000 lines per centimeter. So we are having a grating in which 4000 lines are there per centimeter. So this is the data given for what? To find the grating element, and it is used at normal incidence, calculate its dispersive power in the third order spectrum having wavelength of 5000 angstrom. So what are the given data? We have to accumulate it at 1 plus. So given is, if you want to find A plus B, you have to use 1 upon 4000 lines per centimeter. Then wavelength is given, it is 5000 angstrom. Order of maxima is given, it is 3, and you have to find is dispersive power. So what is the formula? Let's understand the formula first so that we can arrange the equation. The formula is resolving power is either d theta upon d lambda, or it is, yes, how much it is? M upon A plus B into cos of theta. This is the formula for resolving power. फॉर्मूला सेक्शन में मैंने ये रिवाइज करवा दिया था कि रिजॉल्विंग पावर ऐसे कैलकुलेट करनी होगी. So from formula what we understood is we must have m. So m to given है direct. We must have a plus b, that can be calculated directly, but we don't have theta. So from where you can calculate theta? Obviously for that something is there, and what's that? You can use the formula for condition of maxima. So condition of maxima is क्या थी वो? A plus B into sin theta is equals to m lambda or n lambda, where m is order, lambda is wavelength. So can I have sin of theta here? And it will be m lambda upon A plus B. Now what is m? The order given, it is 3 into, where the wavelength given, that was the 5000 angstrom, that is you can say 5 into 10 raised to minus 5 centimeter. Now what is A plus B? It is 1 upon 4000, right? So this 4000 will go up and your sin theta would become 3 into 4000 into 5 into 10 raised to minus 5, right? So sin of theta would be, so sin theta you will be getting here as 0.6. From this you have to calculate theta, and that would be sin inverse of 0.6. You can find sin inverse using calculator. So sin inverse of 0.6, and it is 36 degree and 86, it is 36.86 degree. Why we have found theta? Because we got sin theta, but in our formula we need cos theta. Now what is dispersive power? It is asked to find dispersive power. So dispersive power will be equals to m upon A plus B into cos of theta. What was the m? M is 3, the order is 3. What is A plus B? It is obviously 1 upon 4000 into, what is cos theta? Cos of 36 degree 86, 36.86 degree. Now your dispersive power will be calculated as 3 into 4000 upon cos 36.86, you will be having 0.8, and you have to calculate it, and your answer would be 9600. So what will be the resolving power or dispersive power? It is 9600, right? So here we get the answer for this question. Now moving towards next question, it would be, what is the highest order spectrum which can be seen with the monochromatic light of wavelength 6000 angstrom by means of diffraction grating with 5000 lines per centimeter? Okay, what is the highest order spectrum? Highest order spectrum which can be seen with a monochromatic light of wavelength 6000 angstrom by means of a diffraction grating having 5000 lines per centimeter. So we have to go to the formula of resolving power so that it will give us the maximum number of spectrum or maximum order of spectrum which can be seen. So we have to go for condition of maximum number of order जो मैंने formula की लिस्ट में बताया था. And what is that condition of maximum number? Yes, for that you have to understand the given data first. Lambda is given 6000 angstrom and that will be 6000 into 10 to minus 8 centimeter. Your grating element will be 1 upon 5000 lines per centimeter and required is M max, maximum order. So M max का formula क्या है? Yes, what is the formula? The formula for M max is you have to calculate A plus B upon lambda. So directly data is given. A plus B is 1 upon 5000 and divided by 6000 into 10 raised to minus 8, right? So it would be 1 upon 5000 into 6000 into 10 raised to minus 8. So these 6 zeros will be getting cancelled, remaining minus 2. And it would be 10 raised to minus 2 goes up, gives 10 raised to plus 2 divided by 6 5s are 30. It will be 100 upon 30. It will be 10 by 3. You can say M max is equals to 3, and this is your answer, right? So moving towards the next numerical. A plane grating just resolved 2 lines in the second order. Order number is 2. Calculate the grating element if d lambda is 6 angstrom and lambda is 6 into 10 to minus 5 centimeter and the width of the ruled surface is 2 centimeter. What is to find? Let's understand what is given and what is to find. Order is given, it is second order. D lambda is given 6 into 10 to minus 8, lambda is given 6 into 10 to minus 5 centimeter, width is given 2 centimeter, and you have to find grating element. So grating element you have to find, and for that what we will be doing, but please remember width is 2 centimeter. So you have to find grating element, it is always per centimeter. So please remember you have to find grating element, but the width is 2 centimeter. So when we will be calculating the resolving power, oh, how I realize that resolving power is to be used? D lambda is given, lambda is given. So only one formula is available which includes these two values. So we have to use resolving power, and what is it? Resolving power Rp is lambda upon d lambda, and it is also equals to order into number of lines on grating. So lambda is given 6 into 10 raised to minus 5 upon, or you can use it like both are in angstrom, so you can directly use it as lambda equals to 6000 angstrom and d lambda is 6 angstrom, and that should be equals to order. What is the order given? Yes, order given in the question is order 2 and number of lines. And therefore 2n is equals to, can I have 1000? Yes, and you will be having n equals to 500. So number of lines obtained are 500, but these number of lines are on 2 centimeter width of grating. So what will be the number of lines per centimeter? This is number of lines. This is number of lines on 2 centimeter. Therefore, number of lines per centimeter is equals to n divided by w, the number of lines divided by width. Why we are finding number of lines per centimeter? Because grating element is 1 upon number of lines per centimeter. So it will be 500 divided by 2. So number of lines per centimeter would be obviously 250, right? And then therefore grating element क्या होता है a plus b, and that is 1 upon number of lines per centimeter. Therefore a plus b is 1 upon 250. So how much you get? So a plus b would be 4 into 10 raised to minus 3 centimeter. So you can also convert it into mm or in microns. So this is about numerical number 1.14. Now moving towards next question. In a plane transmission grating, the angle of diffraction for second order principal maximum. In a plane transmission grating, the angle of diffraction for the second order principal maximum for the wavelength 5 into 10 raised to minus 5 centimeter is 30 degree. Transmission grating is there, and angle of diffraction is given 30 degree, but it is for second order principal maximum and with the wavelength of 5 into 10 raised to minus 5 centimeter. Now calculate total number of lines per centimeter of the grating surface. Means you are asked to find grating element again, and for that what is the given? Order is given, wavelength is given, theta is given, and what is required is number of lines per centimeter. So you have to first find grating element, and from that you can calculate number of lines per centimeter. So it is very simple to understand that you have to just use the condition for maxima here. So using condition for maxima, second order maxima you can say, because order is given. So a plus b into sine of theta is m lambda, and here what you have to find is a plus b, that would be m lambda upon sine theta. What you have to do? Put m equals to, second order is given, so put m is equals to 2, lambda is given 5000 Armstrong, then put that value, or 5 into 10 raised to minus 5 centimeter, and sine theta you have to put is 30 degree. So a plus b you will be having 2 into 5 into 10 raised to minus 5 divided by sine of 30. Now calculate it. 10 into 10 raised to minus 5, sine 30 is 1 by 2, 2 goes up, then this gives minus 4, that is 2 into 10 raised to minus 4 is a plus b. Now you have founded a plus b. Also a plus b is 1 upon number of lines per centimeter. Number of lines per centimeter. What is asked to find? Number of lines per centimeter. So convert this formula for number of lines per centimeter, and it will be 1 upon a plus b. What is the value of 1 upon a plus b? So a plus b का value था, yes, how much it was? So it was 2 into 10 raised to minus 4. Now take this 10 raised to minus 4 to the numerator, 10 raised to 4 it would be, and divided by 2. Can I say it is nearly 5000? Yes, not nearly, it is exactly 5000. So number of lines per centimeter it was asked, and it is 5000, right? Now moving towards the next numerical. Monochromatic light lambda equals to 6560 Armstrong falls normally on grating 2 centimeter wide. So wavelength is given 6560 Armstrong, width of grating is given 2 centimeter. The first order spectrum, order is m is equals to 1, is produced at an angle of 16 degrees 17 minutes from the normal, and calculate the total number of lines on the grating. Again same numerical, but last time it was asked to find the number of lines per centimeter, and here it is asked to calculate total number of lines on the grating. So you will be having number of lines per centimeter first and then multiply by the width of 2 centimeter. So what is the given data? Wavelength is 6560 into 10 to minus 8 centimeter. Why centimeter? Because width is also in centimeter and number of lines per centimeters is included in the calculation. Order is 1, theta is 16 degrees 17 minutes. Then convert this theta into degrees alone. So it will be 16.28 degrees. Using calci you can do it. And now how to solve? As same as that of previous question, we can solve it. Here using condition for first order maxima. Very simple type of question it is, but it is asked in previous exam. So using condition for first order maxima, what is it? A plus b sine of theta is equals to m lambda. So you can find a plus b from here, that is be m lambda upon sine theta. Now repeat the procedure. M is equals to, so you can say put m is equals to 1, lambda is 6560 into 10 raised to minus 8, and then theta is 16.28 degree. Therefore a plus b is equals to, order is 1, lambda is 6560 into 10 raised to minus 8 upon sine of 16.28 degree, right? That was 16.28 degree. Now calculate it using calci. So you got a plus b is equals to 2.34 into 10 raised to minus 4. Therefore, from this data, how you can find number of lines per centimeter? Therefore, number of lines per centimeter is obviously 1 upon a plus b, because a plus b is 1 upon number of lines per centimeter. So put the value here, 1 upon 2.34 into 10 raised to minus 4. Now, is it asked to find number of lines per centimeter? No, it is asked to find the total number of lines on the grating, and grating is of 2 centimeter width. So use this number of lines per centimeter and multiply it by width of the slit. Therefore, total lines on grating of width 2 centimeter are, therefore n is equals to width into number of lines per centimeter, and then just put the value. W is 2 centimeter and number of lines per centimeter was 1 upon 2.34 into 10 raised to minus 4. Calculate it using calci. Therefore, you will get the answer 8546.69. You can convert it into 8547 lines. Is it clear? So the next numerical is also previous year asked question. Calculate the maximum order of diffraction maxima seen from plane diffraction grating having 5500 lines per centimeter if light of wavelength 5896 Armstrong falls normally on it. So इसके जैसा न्यूमेरिकल हमने पहले भी देख रखा है, right? What is to calculate maximum order of diffraction, right? And for that, what is given data? Number of lines per centimeter is given. From that you can find grating element, and then wavelength is given. So I hope you understood what is asked here, because previously we have solved same type of numerical. So let's move towards the solution. So the given data is number of lines per centimeter is given, which is 5500 and it is obviously the reciprocal of grating element, and lambda is given, and what is to find is maximum orders that can be visible. So I hope you must remember the formula for maximum is M max, or condition for maximum order of diffraction observable is A plus B upon lambda. A plus B upon lambda. So what is your A plus B? It is 1 upon number of lines per centimeter and then divided by lambda. So put the value and find M max. So can I say 1 upon number of lines kitna hai? 5500 into lambda, this because this will come to multiply the lambda. Lambda is 5896 into 10 raised to minus 8 centimeter. Now just do calculate. So the answer is 3.08. Now just do rounding off and M max will be 3. So maximum third order diffraction can be seen from this grating. Now moving towards the next numerical. A diffraction grating used at normal incidence gives a yellow line of wavelength 6000 angstrom in a certain spectral order and superimposed on a blue line of wavelength 4800 angstrom. Say, try to catch the given data. That wavelength of yellow line is 6000 angstrom and blue line is 4800 angstrom, but the important thing is they are superimposed, means they are coinciding each other. Of next higher order, if the angle of diffraction is sin inverse of 3 by 4, angle of diffraction is given sin inverse of 3 by 4, then calculate the grating element. What you have to find is A plus B. So for that, what is the given? It is lambda 1, lambda 2, yellow line and blue line ka wavelength, both are given, and then theta is sin inverse of 3 by 4. You can convert it for sin theta. Why? Because in the formula of grating element we will be having sin theta along with it. Now how to solve it? Very simple, using condition for maxima. Produced by yellow and blue line. Obviously two wavelengths are there, so you have to use it 2 times. Therefore A plus B into sin theta is equals to n lambda, but 2 wavelengths are there. It means here it is lambda 1. This is say equation 1, and then again for second line, that is the next line of yellow, A plus B into sin theta would be, it is given that it's a next line. Here it is blue line of next higher order, means if we are taking n for yellow line, you have to take n plus 1 for blue line because it's a next higher order. So you obtain 2 equations in which LHS is same, so RHS must be same. So equating 1 and 2, what you get? Equating 1 and 2, what you get? N lambda 1 is equals to n plus 1 into lambda 2. Now what are the values of lambda 1 and lambda 2? Lambda 1 is 6000 angstrom and lambda 2 is 4800 angstrom. Put the values over here. So first solve the equation, simplify it. N lambda 1 is equals to n lambda 2 plus lambda 2. Then shift this n lambda 2 towards LHS. You will get n lambda 1 minus n lambda 2 is equals to lambda 2. Make n common and you will be having lambda 2 upon lambda 1 minus lambda 2. What is lambda 2? 4800 angstrom upon lambda 1 minus lambda 2, 6000 minus 4800, and you will be having 4800 divided by 1200. So it will be 4. So what is the order of yellow line you found? It is 4th order maxima. Why we founded this order of the yellow line? Because we want to find grating element, and in the grating element formula n must be known if you want to find a plus b as an unknown. So moving ahead, we got n is equals to 4 and then solve it for yellow line. Therefore order of maxima as 4 for yellow line, for lambda 1. Lambda 1 was the yellow line. Then again put in the formula, put in equation 1. I hope you remember equation 1. It is a plus b into sine of theta is n lambda 1. So here a plus b is unknown, sine theta is n is 4 into lambda 1 is 6000 Armstrong, that is 10 raised to minus 8. Angle is sine, therefore a plus b into 3 by 4 is 4 into 6 into 10 raised to minus 5 is 4 into 6 into 10 raised to minus 5. So a plus b would be 4 into 6 into 4 into 10 raised to minus 5 divided by 3. So 3 2s are 6, 2 4s are 8, 8 4s are 32 into 10 raised to minus 5. You can say 0.32 into 10 raised to minus 3 is your a plus b in centimeters, right? This is the grating element which was asked in the question. And remember, these are the questions which are previous year asked questions. So the types which we are discussing here will be important in the exam point of view. Moving towards next numerical. The visible spectrum ranges from 4000 to 7000 Armstrong. So there is a range of wavelength given, 4000 to 7000 Armstrong, and find the angular breadth of first order visible spectrum produced by a plane grating having 6000 lines per centimeter. Range of wavelength is given and you are asked to find the angular breadth of first order visible spectrum produced by plane grating, and what is the number of lines per centimeter? It's a 6000 lines per centimeter on the given grating when light is incident normally on the grating. Let's try to first understand and visualize the diagram of what is this angular breadth. So if you are having two wavelengths, then you will be having two angle of diffraction. So this would be the theta 1 minus theta 2, and that is the angular breadth of first order. So m is 1. So this is angular breadth which is asked to find, and you can visualize that this is in between these 2 points. Let's understand what is the given data in a solution. So given is lambda 1 4000 Armstrong, lambda 2 is 7000 Armstrong. To find the grating element, the number of lines per centimeter is also given. Order of maxima is 1, and you have to find angular breadth, which will be theta 2 minus theta 1 of the first order visible spectrum. So how will you obtain this theta 1 and theta 2? Simply using condition for maxima. You can say first order because order is given, first order maxima. And what is the condition? A plus b sine of theta is equals to m lambda. But as two wavelengths are given, you have to find two thetas for them. So put it as sine theta 1 and lambda 1. Obviously grating element remains same for both the wavelengths. So now sine of theta 1 will be m lambda 1 upon a plus b. So what is m1? What is lambda 1? Yes, wavelength was given 4000 angstrom, that is 4000 into 10 raised to minus 8 centimeter. Why centimeter? Because number of lines involved in a grating element were in centimeter. So a plus b, what is a plus b? It is 1 upon number of lines per centimeter. Obviously this number of lines per centimeter will go up, and you will be having 4000 into 10 raised to minus 8 into, what is the number of lines given? It is 6000. Then just do the calculation. You will be having, so doing calculations, 24 into 10 raised to minus 2 is your sine of theta 1. Then theta 1 would be sine inverse of, make shifting of these two decimals, you will be having 0.24. So 10 to the power minus 2 will be become 0. So theta 1, just do it on calci, and you sine inverse of 0.24, you will be having angle as 13.88 degree. Very similar to this way, you have to find theta 2, right? So let's find theta 2. Therefore a plus b sine of theta 2 would be m into lambda 2. Now just we have to find theta 2 for second wavelength. So a plus b will remain same. So sine of theta 2 is m lambda 2 upon a plus b. The order is 1. Lambda 2 is 7000 angstrom, that is 7000 into 10 raised to minus 8 centimeter, upon, what is the replacement of a plus b? It is 1 upon number of lines per centimeter. So it goes up in the numerator, 1 into 7000 into number of lines is 6000 into 10 raised to minus 8. Now cancel out this, going minus 2, and it would be 0.42 for sine of theta 2. Then how to find sine theta 2? That is sine inverse of 0.42. Theta 2 is sine inverse of 0.42. So theta 2 is 24.83 degree. Is it asked to find theta 1 and theta 2? No. It is asked to find angular breadth. Therefore angular breadth of spectrum, angular breadth delta theta will be theta 2 minus theta 1. So delta theta would be, what is theta 2? 24.83 minus theta 1. What was theta 1? 13.88. And if you solve this, you will be having answer. You will be having answer 10.95 degree. Right? So this is all about numericals on diffraction grating, and in this second part of numericals we have discussed previous year asked numericals which are important in the semester end exam. So thank you for watching this.